Stay hungry, stay foolish.
Nearly all scientists who study the biology of aging agree that we will someday be able to substantially slow down the aging process. Today's guest is perhaps the most bullish of all such researchers and believes that the key biomedical technology required to eliminate aging-derived debilitation and death is now within reach. In his book, he and his research assistant Michael Rae describe the details of this biotechnology. They explain that the aging of the human body, just like the aging of man-made machines, results from an accumulation of various types of damage. As with man-made machines, this damage can periodically be repaired, leading to indefinite extension of the machine's fully functional lifetime, just as is routinely done with classic cars. We already know what types of damage accumulate in the human body, and we are moving rapidly toward the comprehensive development of technologies to remove that damage. By demystifying aging, our guest systematically dismantles the fatalist presumption that aging will forever defeat the efforts of medical science. We welcome the author of Ending Aging, the rejuvenation breakthroughs that could reverse human aging in our lifetime, Dr. Aubrey de Grey. Welcome to the show.
Thank you for having me.
It's fantastic to have you on the show. I wanted to open, Aubrey, with a quote by Graham Hancock. It goes like this: "This is how it is with every paradigm shift. It happens because little by little, drip by drip, new evidence keeps coming in that can't be explained by the existing paradigm. And at a certain point, it becomes clinically insane to go on defending that existing paradigm. It takes great courage to step outside what's considered the norm. And for that, sir, this show and I want to tip the hat to you for your fantastic work to step outside the norm."
Well, you're very kind.
I thought it would be useful to start with an explanation of what SENS is, Aubrey, and what's your mission.
The best way to define SENS is to start by defining aging. And of course, the reason why that's necessary is because different people have different ideas and generally rather poorly defined ideas about what aging is. The best way, I think, to define aging is as the combination of two processes: a process that happens throughout life and a process that happens late in life. The one that happens throughout life is that our bodies create damage to the body. In other words, changes to the microscopic structure, the molecular and cellular structure of the body, that are side effects of the way that the body normally works to keep us alive from one day to the next. And these side effects are initially harmless because the body is set up to tolerate a certain amount of them. But eventually, the body has more damage than it is set up to tolerate, and that is when the damage starts to kick off the second process, which is the decline in function of the body, the gradual progression of chronic mental and physical dysfunction, and eventually death. The reason why I think that it's good to highlight the analogy with simple man-made machines, we have the same definition there. We can, for example, consider rusting as a side effect of the normal operation of a car. And of course, rusting is initially harmless for a car because the car is set up to work fine with a little bit of rust. But eventually, there's too much rust and the doors fall off. So it's really exactly the same. And that turns out to be useful as a way of demystifying aging. So then what is SENS? SENS is essentially a damage repair paradigm. The idea is that we allow damage to happen because we can't stop it from happening, but that we periodically eliminate the damage from the body, not necessarily perfectly, but we eliminate a fair amount, so that we keep the overall load, the overall amount of damage in the body, down below this amount that the body is set up to tolerate. So that's equivalent to removing the rust every so often from your car. Now, the reason that this is so controversial, or rather was so controversial when I started putting it forward nearly 20 years ago, is that for the previous many decades, people who were studying the biology of aging were looking at a completely different paradigm for postponing the health problems of late life. Namely, they were looking at trying to make the body run more cleanly in the first place and lay down damage more slowly than it normally does. And that was inspired by the observation in the living world that some species lay down damage much more slowly than others because they've got better machinery for avoiding damage. But of course, we haven't actually had any success in that paradigm. And this is essentially because the creation of damage is so unavoidably and intrinsically bound up with the operation of the body, the metabolism that keeps us going from one day to the next. So the damage repair approach is actually much more practical. And at this point, 19 years after I first started thinking in this way, I can confidently say that, in fact, this damage repair paradigm is really the dominant, mainstream, orthodox way of thinking in this regard.
And it's very difficult for people to get their heads around this. Like any paradigm shift, we've been born into this paradigm. And one of the hurdles that I always hear when I mention this to people is that, what will we do when we're older? Does this mean just dragging out years of pain, etc.? But you talk about, as you say in the book, ending the horror show altogether.
Well, this is right. Yeah. I mean, it is really quite shocking how irrational most people are about this. So the paradigm shift that I talked about a moment ago was, of course, a paradigm shift within the field of biogerontology, among the small coterie of people who actually study the biology of aging. But there's another paradigm shift that you're alluding to that has to occur within society, which is to understand that aging is a medical problem, and that therefore we have the opportunity and indeed a moral obligation to develop ways to prevent it using new medicines and to keep people healthy late in life. Now, the idea that there would be some kind of downside to this has to be examined rather carefully because, in fact, people are very prone to invent some potential hypothetical downside from this and then just completely uncritically presume that their idea is true and therefore that the defeat of aging is a bad thing. And one of the most famous is the one that you just mentioned, that people jump to the conclusion that medical intervention in aging would constitute simply keeping people alive in a poor state of health, which is typical of how people are late in life today, when in fact the proposal is the exact opposite, to actually extend the youthful period of life and postpone the health problems of late life, with the increase in longevity being simply a side effect of that.
And one of the things you say, and you say this in the book, and the book was 20 years old when you started doing the research. It was published, the one I have, in 2008. And I don't know if the figures are still accurate, but then you said around 150,000 people die each day worldwide. And of those, 2/3 or 100,000 die of aging. Yet we have not addressed the problem of aging yet.
That's right. And in fact, yes, you're quite right. Those numbers, I can update them a bit. The number of people who die in total worldwide each day is now around 155,000, and the number who die of aging is about 110,000. So actually the proportion of deaths that are due to aging has gone up. It's over 70% now.
An objection I hear, Aubrey, and you cover this brilliantly, and I really highly recommend people look at your TED Talks because you challenge people. Come at me, bring me the challenge. I've heard them all. But one of the ones that people come with is that nature has adapted towards aging and death anyway in a kind of a natural circle of life. But that's not always the case. And you alluded to this in that some species have already adapted beyond aging.
Well, they have. However, I don't really view that as a particularly strong challenge to the paradigm that we can medically control aging. I think a better one is simply to say that nature has adapted to the presence of infections and the high mortality rate in infancy, for example. But lo and behold, we figured out how to fix that. 200 years ago, about 40% of all babies would die before the age of 1, even in the wealthiest countries in the world, and now hardly anybody does. So, the sky doesn't seem to have fallen in. And it's going to be exactly the same when we correspondingly figure out how to keep people healthy late in life.
And then the other objection that you often hear is overpopulation. So this idea of the world's overpopulating already and we're exhausting the resources. And you do call this out, that the sands of time are fading away, but the problem is not fixing aging or solving aging or ending it. The problem is if we run out of the resources on the earth and we destroy that first.
Well, precisely. I mean, the whole idea of so-called overpopulation is not a problem of lack of space. It's a problem of the amount of pollution that the average person creates per year or whatever. And of course, the main pollution that we notice the consequences of at the moment is the burning of fossil fuels and such like, the change in the composition of the atmosphere, leading to climate change. And of course, we're already fixing that. There are other technologies coming along right now. Renewable energy is in the process of replacing fossil fuels, not even by virtue of the world having actually woken up and decided that climate change is rather a bad thing. It's just because technology has advanced to the point where renewable energy is cheaper than fossil fuels. And of course, the same is in the process of becoming true with regard to artificial meat, which will, within a rather short amount of time, be both tastier and cheaper than normal meat, which of course will also have a huge impact on the amount of greenhouse gases released as a result of agriculture. And you've got a bunch of other technologies that fit into the same kind of pattern, desalination, for example, becoming extraordinarily cheap. So the carrying capacity of the planet, the actual number of people that we can have on the planet without an unacceptable level of environmental impact, that carrying capacity is absolutely certain to rise much more rapidly than the population will rise, whether or not we defeat aging.
And I was thinking about this, and I was thinking about the challenges that you lined up, and you do it brilliantly in the book. You line up all these challenges and you go, this is a massive challenge that I'm taking on. And I can't just solve aging and the breakdown of processes that kill us as a result of aging. We have to actually deal with them together and in line. And here you say, we are constantly urged to clean up our lifestyles and practice preventative medicine. Surely we think it makes more sense to put our energy into attempting to interfere with the causes of aging and age-related diseases than to try to undo an established molecular mess. But the causes of aging lie in the fundamental chemistry of life, and our capacity to interfere beneficially with that chemistry is limited by what the organism's underlying biology will accommodate. I'd love if you expanded on this, because I think this is really one of the things that really dawned with me.
Yeah, sure. Yeah, I mean, it is certainly the case that the overwhelming majority of medicines that we have today are designed to cure this or that so-called disease. Now, medicines that cure infectious diseases, that's a thing. You can actually give someone this medicine and you eliminate the disease from the body so that the person doesn't actually, experience the disease again unless they get reinfected. Fine. But if you look at the so-called diseases of late life, like Alzheimer's or almost all cancers or atherosclerosis and so on, then, the idea that we could actually cure them is just illogical. Because these things, the only reason they can be specific to older people is by virtue of being a consequence of aging, a part of aging. They have to be simply the later stages of an initially harmless process that goes on throughout life. So the only way to fix that is by being more preventative. And as I say, there are two general schools of thought that one can have with regard to that. One is to slow down the rate at which the body does the early stages of that process of creating these eventual problems. And the other is to reverse that process by repairing damage after it's been laid down. And the breakthrough, the insight that embodies sense, is simply that the latter alternative, the removal of damage after it's been laid down, is much more practical than the former, the slowing down of the creation of damage.
And why is that, Aubrey? Because that one's really interesting. And because you talk about this, it's like a kind of a domino effect, a negative domino effect, where you might clear an issue like cancer and then all of a sudden Alzheimer's pops up and you're kind of going, you need to line them all up and hit them all at once. And this is key to the whole sense work.
Yes, this is a divide and conquer approach. And actually that was one of the reasons why the majority of my colleagues studying the biology of aging were rather slow to appreciate the logic of what I was saying when I first started talking about this in the early 2000s. Because, you see, the geriatric paradigm of actually trying to genuinely cure these pathologies of late life is also a divide and conquer problem. But it's an impractically large divide and conquer problem, a kind of whack-a-mole problem, where you're getting so many things going wrong with the body at more or less the same time and interacting and exacerbating each other. And really the whole field of studying the biology of aging is a result of the realization from more than a century ago that this approach is just never going to work because there are too many things that go wrong. However, the thing about repairing damage, which is essentially intervening at an earlier stage before people get sick, is that even though it's a divide and conquer problem, it's a much more manageable one. There's only 7 major types of damage that accumulate in the body as consequences of the body's normal operation. And for each of those 7 types of damage, there is a corresponding potential repair therapy. And when I say potential, some of them are closer to implementation than others. Some of them are already in the clinic. But once one looks closely at the details, one can see that it's a much less daunting divide and conquer problem than the geriatric paradigm.
You line up those 7, you line up the list and you go, let's solve it this way. Let's look at the list. What's the problem? Set them up and then actually look what corresponding technologies exist and what will exist. Because we can map things out in the future and we know we may not be able to deal with it now, but we're close. And I'd love if we delved into that list and explained in simple terms what the list items are, because I've never heard this on a show before. I've never heard somebody go, here's actually the 7 things that most likely kill us. And if we remove those, we might be able to extend aging to begin with and maybe end it altogether.
Yeah, I mean, these 7 things are easy to describe, easy to define. They're concrete, clear, well-known phenomena that happen in the body as a consequence of being alive. And furthermore, it is known that they are eventually bad for us when there's too much of these accumulation. Of course, repairing that damage is the thing to do. And as you say, yes, I proposed a damage repair strategy for each of them. Most of these proposals were not new in the sense of no one had thought of them before, but a few of them were drawn from areas of biology that were not related until then to the biology of aging. In other words, they had been developed by other biologists for other reasons, and I was kind of co-opting this work. And that was another part of the reason why the adoption and recognition of the attractiveness of this approach was a little slow. And my colleagues in the biology of aging had to essentially get up to speed on these other areas that had not previously been relevant to their work.
So you mentioned there one of the key things is you've got beyond the silos. And unfortunately, this happens in so many industries, including in the medical industry, where people have great thinking, but it's all separated. And you're joining the dots between all this information, which is one of the key tenets of innovation, is looking beyond the best practices and looking for best principles and joining all those different minds together. But I'd love if you delved a little bit into that list, Aubrey, particularly the 7 major elements that kill us.
Sure, yeah. So just going very quickly through the list, 3 of the 7 types of damage are to do with the number of cells that we have. So the first one is simply having too few cells of a particular type. And this happens if cells die and they are not automatically replaced by the division and differentiation of other cells. So, of course, that's not the accumulation of some physical thing. Rather, it's the loss of something we need. It's the equivalent of tiles falling off your roof, for example. But we still call that damage. So that's the first one. The other 2 are with regard to having too many cells of a bad type, cells that we'd rather not have. And that happens for 2 types of reason. That's why we have 2 different categories. One reason is that cells are dividing when they're not supposed to, so we just have too many of them per se. Even though the cells themselves may be functioning, there's just too many of them. And of course, that is more or less the definition of cancer. And then the other one is when cells don't die when they are supposed to. In other words, they just hang around and they cause more trouble, they do more harm than good. And the body may try to eliminate them, but it doesn't succeed. And that turns out to be quite important in the aging of the immune system, for example. Okay, so those are the ones to do with cell number. The other ones are molecular. So there are 2 things that go wrong inside the cell. One of them is mutations in the DNA that lives inside a very important part of the cell called the mitochondrion. So mitochondria are the machines within cells that perform the chemistry of breathing. They combine nutrients with oxygen to extract energy from the nutrients. And that process is very hairy and it creates toxic molecules called free radicals. And for that reason, it damages DNA. So the accumulation of that damage is very important. It turns out that mitochondrial DNA accumulates damage much, much more rapidly than the DNA in our normal chromosomes in the nucleus. The other type of damage within the cell is simple waste products, stuff that the cell creates as a byproduct of its normal operation, but that the cell does not have any mechanism to destroy or to excrete. So it just accumulates, typically in a kind of incinerator called the lysosome. And eventually there's so much of that stuff that it's a bit like not taking the garbage out of your kitchen for a month. Okay, so that leaves just two more types of damage, and these are things that happen outside the cell, in other words, in the spaces between cells. One of them is, again, the accumulation of garbage, waste products, and the other one is the accumulation of molecular changes, molecular crosslinks, essentially chemical bonds between long-lived molecules that are involved in giving our tissues their physical properties, especially their elasticity. So this is a major contributor to hypertension, for example, because the major arteries become less elastic. And it's also the exact same chemistry is heavily responsible for wrinkles, so it has cosmetic consequences as well. For each of those 7 types of damage, there is a corresponding generic approach to dealing with it. For loss of cells, you've all heard of the answer, which is simply stem cell therapy. We put cells into the body that know what to do, that we've prepared in the laboratory to be able to divide and differentiate to replace the cells that the body is not replacing on its own. For cancer, there is, of course, a wide range of different ideas, but there's particular progress recently on using the immune system against cancer. There's great promise there, and there are also a bunch of other ideas that we've been pursuing for taking that forward. Then, for getting rid of these cells hanging around and not dying when they're supposed to, that's actually something that's seen great breakthroughs in the past few years with the development of drugs and other methods that can selectively eliminate these cells. There are approaches that we've been pursuing for a number of years, and also other approaches that have had great success. So especially there's a subset of this type of cell called senescent cells, which are very important in this area. Then for mitochondrial damage, DNA damage, basically we are pursuing an approach that involves putting mitochondrial DNA backup copies into the nucleus, into our normal chromosomes, where it's much less susceptible to damage. That's not so hard as it sounds, though it is actually pretty hard. But the idea is basically we have to modify the DNA so that it still works even though it's in the wrong place, and we are getting close to getting that working. Then, for getting rid of waste products in the cell, essentially what we're doing is identifying other species, especially bacteria, that have the genetic machinery to break down these substances, and we incorporate those genes into human cells. Finally, then, for the things outside the cell, first of all, for waste products, it turns out that all we need to do is get those waste products inside the cell, and then it's kind of reduced to the previous problem. But actually, it's better than that, because the stuff that accumulates outside the cell is intrinsically already amenable to destruction so long as it gets inside the cell. So we can basically just vaccinate against this stuff. And that's, again, something that's already working quite well in certain cases. And finally, getting rid of these crosslinks, again, we need to develop enzymes or possibly small molecule drugs that will simply break these unwanted accumulating chemical bonds. And again, we've seen some great breakthroughs in work that we funded over the past few years.
You're solving so many of the mechanical issues. So you've either, your team and your research has shone a light on it for people to solve these problems. But the real challenge is going to be a humanic issue, if you want to call it that. It's a human issue where people change their perception and they change their paradigm of how things happen and how age happens. Because I was thinking of the Roger Bannister effect. Until 1954, nobody thought it was possible to beat a 4-minute mile. He beats it. Within 2 months, somebody else beats it. And within 5 years, it's beaten again twice, because he opened the floodgates of this is possible. And I think that's one of the huge challenges we have. And one of the reasons I wanted to have you on the show, you liken it a little bit to smoking and the way that every packet of cigarettes says smoking kills, yet people still smoking. But that's changing because there's been a light shone on it, because there's been campaigns done on it. And I think we need to do the same about paradigms like this, shifting paradigms, changing paradigms about aging as well.
That is completely correct, yes. I mean, certainly the fatalism that exists in society is slowing this work down because it is reducing the amount of public resources, money that is spent on hastening the defeat of aging. And of course, this is not surprising because until I came along, basically, until we had this damage repair paradigm that actually had a practical chance of being implemented, we didn't have a plan. That humanity did not have any coherent strategy for keeping people healthier late in life. So the only option that existed since the dawn of civilization, when we realized that aging exists at all, was to kind of put it out of our minds and get on with our miserably short lives and make the best of it. And of course, the thing is, it's rather hard to put something really grim that's going to happen to you in the future out of your mind. So we've had to construct a wide variety of extremely illogical ways of thinking in order to do that. We've had to somehow persuade ourselves that aging is some kind of blessing in disguise, or that aging is so different from diseases that it's kind of off limits to medicine and it's just inevitable and natural and it's kind of a phenomenon that nothing can be done about. And both of those things are just completely at variance with established fact. So it's a bit of a shame that people had to think that way, but it made sense, this kind of rational denial, until sense came along. It's only now that it's a huge part of the problem.
I heard once that life is like a sexually transmitted disease. You catch it and then you die. And unfortunately, that's the way we think. It's like handing in, the way a cigarette packet has smoking kills, handing out babies and going, birth kills, like life kills. And that's one of the huge problems. But I think, if we spread this word and change little by little how people think, maybe we might make some progress. One of the things I wanted to ask with that was, you reckon people who are already born, the first person who will live to 200 is already alive today?
Well, actually, I can say a stronger statement. I think that we have at least a 50-50 chance of getting all of these damage repair therapies that I listed earlier working pretty well, working in combination within the next 20 years, perhaps even a little less than 20. And that means that they will be in time for not just one person, but most people who are alive today. Because, of course, since it's damage repair, we will be actually taking people who are already in middle age or older and genuinely rejuvenating them, taking them back to being biologically younger again, having less damage in their body than what they had before. Now, these therapies will not be perfect at that point. I believe that probably they will only give us an additional maybe 20 or 30 years of healthy life. But the thing is, that healthy life will be given, because it's to people who are already in middle age, it will buy us time. It will get us to the point where, 30 years down the road, these same people will be biologically middle-aged again, but we will be able to re-rejuvenate them with improved therapies that have been developed during those 30 years. So that leads to the conclusion that we actually have an extremely high chance that anybody who benefits from this initial first-generation panel of interventions, which I think has a good chance of materializing within the next 20 years, will actually never have to get sick as a result of having been born a long time ago, which means that we could be talking about numbers much larger than 200. But again, I always have to emphasize that we shouldn't really be thinking about longevity, because longevity is just a side effect of health. And, all of the irrational reservations and concerns that people raise with regard to the medical control of aging revolve around the fixation on the longevity side. If we just remember that this is all about health, then it's not controversial at all.
It's kind of just like kicking the can down the road, but you're talking about first, let's extend the runway. That'll give us more time to continue to extend the runway, and then we won't need a runway anymore. We won't need to extend, and we'll be in a different paradigm altogether. But one of the things you do in the book is you call upon so many studies that exist, and there's many studies that exist in mice. I'd love if you shared this, because this backs up so much of what you're saying here, that they've already extended life by 20% in mice.
Well, we must actually be rather careful about that. So, yes, absolutely. We've been able to extend longevity in mice, and of course healthy longevity, postponing the health problems of late life, by actually considerably more than 20%, more like 40 or 50%. However, the bad news is that we were already able to do that in the 1930s. So, it looks a bit dodgy that we haven't actually significantly improved on that in the subsequent nearly century. However, that's okay, because it turns out that the ways in which we were able to do that in mice and rats for so long are ways that don't scale. Those are not the ways that we are going to succeed in postponing aging in long-lived species like humans. Therefore, the only reason why there's been this, flatlining of the amount by which we can extend life in mice or rats is because these therapies that I'm talking about, these damage repair approaches, don't work in mice or rats yet either, but they will.
And some more studies you mentioned are Michael Rae's fruit flies and also Tom Johnson's nematodes. There's a little bit of research here that gives us optimism.
So, of course, much shorter-lived species like fruit flies or nematodes can also have their lives extended by interventions. And in fact, in the case of nematodes, we can now extend life by a factor of 10. But unfortunately, these approaches also don't scale. The corresponding approaches simply don't give the same proportional increase in life to longer-lived species, even to mice or rats. So we have to stand back and ask, what are the differences between different species that motivate different approaches to keeping people healthy?
One of the things that I wanted to ask, because I know you need to move on, is the impact on society. I mean, we're not ready for this. I mean, people get life assurance and now they're going to need insurance in case they live. It's not going to be in case you die, it's in case you live, because what are you going to do when you retire? It's going to change the whole idea of having a vision and purpose for your life. It's going to change the whole idea of having a relationship, because you're going to live together for a very long time, and that's going to change the paradigm, and the impact is going to be huge.
You're absolutely right, and this is not being thought through nearly enough. So when I give talks and interviews, I very strongly emphasize that it is vital for people to actually get their heads around this quickly. You see, the thing is, people are inclined to say, well, I'll believe it when I see it, and we can figure it out when it happens. And the basis for that way of thinking is simply that even if we do develop these therapies that defeat aging, people are only going to actually get older at 1 year per year. We won't actually have any 200-year-old people for at least another 100 years, whatever happens. So we can kind of figure it out as we go. And that sounds awfully reassuring, but it's completely wrong. Because actually what matters is how long people expect to live. That's the thing that determines things like what kind of insurance policy they want, whether it's health or life insurance, what kind of pension they want, things like that. And what I am pretty sure is going to happen, and furthermore, this is not going to be 20 years from now, this is going to be probably less than 5 years from now, what I think is going to happen is there's going to be an extremely sudden and massive change in how long people expect to live. Because suddenly the reality of the work that's already going on in the laboratory is going to hit society. People are going to realize, oh my God, we are actually on the cusp of being able to do these same things in humans. And progress being what it is, it's going to be able to get to this point that you described earlier, this where we stay one step ahead of the problem. So suddenly, literally overnight, people are going to go from expecting to live only a few years longer than their parents did to expecting to live essentially forever. And that is when the shit's going to really hit the fan, so to speak, when people are going to start changing how they spend money, how, big ticket items like the ones I just mentioned, how they plan for inheritance, how they do a lot of the most fundamental things in their lives. And if we're not ready as a society, top policymakers and opinion formers, if we haven't thought that through before society wakes up to this realization, then the transition into a post-aging world is going to be much more turbulent than it need be.
It reminds me exactly of the problem with disruption in businesses. If you leave it until the platform is nearly burnt out or it's too late, you only stand a 10% chance of survival. And it's the same if you want to jump careers. You need to build capability well before the need to do so. We had Bruce Lipton on before, and he talks about the biology of belief, and that when people believe something, they stand a much more chance of achieving it. And here he talked about telomeres, and I know you're under pressure to head on, but I'd love if you shared this, because this has a huge impact. And one of the ways telomeres are elongated is by having a vision for the future and having a purpose for your life.
Well, Yeah, kind of. So, telomeres are, for those of you who don't know, the ends of chromosomes, special sequences of DNA that protect the ends of chromosomes from fraying, basically. Those telomeres get shorter during life, and some people think that a good idea for keeping people healthy would be to counteract that by using an enzyme called telomerase that extends telomeres. And there is plenty of evidence that that might have some good, indeed, some rejuvenating effects. It may be that we have to be rather selective about it because it may actually be bad to extend telomeres in the case of cancer, but the jury is still out on that. However, what you're alluding to is that the natural rate of shortening of telomeres is affected by certain things, and one thing that's affected by it seems to be stress. So people who have very stressful lives, especially people who are very poor at handling stress, tend to have an accelerated shortening of their telomeres, and they tend, sure enough, to live less long. Centenarians, if you look at 100 centenarians, they don't have much in common. But one thing they tend to have in common is nothing bothers them. They're very good at coping with stressful situations. And it is indeed believed that this contributes to their longevity.
Brilliant. And Aubrey, where can people find out more about your work?
So, of course, the focus of my work is Sense Research Foundation, which is a charity based in California. And naturally, we have a website, sense.org, S for sugar, E for elephant, N for November, S for sugar.org. And there is massive material there. There is plenty of stuff for experts and also plenty of stuff for complete novices. And there's lots of news about what's happening and how rapidly it's happening and whereabouts in the world I'm going to be speaking next, things like that. And of course, there's a nice friendly donate button.
One last question is, you're mic'd up to the rest of the world. You have an opportunity to tell everybody one thing. What is the message that you want to get across?
Aging is a medical problem that we are within striking distance of solving. In other words, we are in the foreseeable future very likely to be able to keep people healthy however long they live. That, therefore, means that we have a moral obligation to do so as soon as possible, so as to save more than 100,000 lives a day, and in particular, to alleviate the astronomical amount of suffering that aging currently causes.
You tell us in the book, biologist John Haldane said, when it comes to any new concept, there are 4 stages of acceptance. This is worthless nonsense. This is an interesting but perverse point of view. This is true but unimportant. And 4, I always said so. I look forward to when you reach stage 4, Aubrey, author of Ending Aging, the rejuvenation breakthroughs that could reverse human aging in our lifetime. Dr. Aubrey de Grey, thank you for joining us.
Well, thank you very much for having me on the show.